Hey everyone. So we will be today we will be learning about linked list. So we will be discussing what is linked list. Let me write here. So what is linked list? Then we will also learn about why linked list. Uh, what are the properties of linked list? And finally, how to create it. We'll be learning from the very basics and fundamentals. So and you will at the end of the video will completely understand the properties and what is linked list. So linked list is a sequential data structure. Now what do we mean by sequential? You can also call it a linear data structure. So what does it mean? It means that data are that just like array, the elements are accessed in a linear order. We access first, the next and the next. uh, so linked list looks something like this. So we have a node, then we have another node, this and then this. Each node has two properties. It contains the value of the node as well as the uh, reference to the next node. So what will one contain? One will contain its own value 1 as well as which is the next node in the list. So it will also contain the address of 2. So that we can access the next element of the linked list, and it will be accessed one by one. Uh, Next, let us understand why linked list. So why? Why do we need to study about linked list? There are two important properties about linked list that makes them useful in certain situations. First one is they do not require continuous space in memory. And next is insertion at the front can be done in constant time. So let us discuss them one by one. They do not require contiguous space in memory. Now you may be familiar that array require contiguous space in memory. That is, if we are given with an memory location, let's suppose we want to store 5 array elements. So it can and assuming this one is filled, this one is filled, this one is filled. So assuming that we require 5 elements, so we can, in this case, we can assign array, and it can be the elements can be assigned here, 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 here. So we can assign 5 spaces for the array. Now let us suppose we require to store 7 elements. How do we store it using the array? The answer is we simply can't. Array require contiguous space memory, and since there is no 7 spaces available, 7 contiguous spaces available, we cannot store 7 elements in an array. We can break the array into two parts, let's suppose in 2 elements and 5 elements or 6 or 1, but we cannot store all of them, all of the 7 elements in the single array. That's where linked list come to the rescue. In case of linked list, if we wanted to store 7 elements, we could store one element here. It can contain the reference to the next pointer. Let's suppose 2 we can store here. Then 2 may contain another reference to this. So it will contain the address of this value 3. 3 may contain value of address of 4. 4 may contain address of 5. 5 may contain address of 6, and 6 may contain address of 7. So as we can see, using linked list, we do not require contiguous space. So if there are 7 spaces available, linked list would be able to utilize the space, so that leads to better utilization of the memory. Next is insertion at the linked list can front of the linked list can be done in constant time. We will discuss this later in the video. Next, we will discuss the properties of the linked list in terms of time complexity. So what are the properties? Let's make a chart. Okay, and insertion, access, deletion, at head, at any random, at tail. So insertion at the head takes O of one time of memory. At any random position it takes O of n, and it may, depending on how we implemented it, it can be done in O of one time also, but usually it is done in O of n time. Access will always be O of n, so O of n, O of n. In case of head we can say it O of n, but it is simply O of n because this is the first element. And deletion, it will be at O of 1 at any random position O of n and O of n. Now let us discuss how to create a linked list. We will discuss all this time complexity and how we get it in the next lecture. In this lecture we will keep our lecture short and simple and understand how to create a new linked list. So creating a new list is simple. First of all, before creating the linked list, we will create a class for the node. So class node, and node, as we know, node will be having two properties. Its value and the reference to the next. In if nothing given, we will assume that next is null or none. So we will initialize this value self dot value to be value given, and self dot next is next. So simply we have defined node. So now let us define a function for creating a new linked list. Diff create ll. We will be given with an array, and we can. So now the process for creating the linked list start. Initially we will define a dummy head and make its value to be none. So initially our linked list will look something like this. I am using forward slash to denote a none pointer, a none variable. Next we create another variable current node to store the next to create our linked list. Initially it will be assigned at head, and now our process start. So for we loop through each element in the list, and we create a new node, new node, and its value will be the num. Then we will assign next pointer of current node to be this node. Next is equal to new node, and we will move on to the next node. And therefore we will return head dot list. I will explain how this line comes. First let's look at how it is created. So initially I have created a dummy node, head node, and let's suppose our array is something like 3, 4, 5, 2, 7. So current node head will be here, as well as our current node. Initially, this is our initial configuration. Next, 3 come. So first of all, we will create a new node with the value 3. Mark its next pointer none. Now join the node with the previous node. So current node will act as the previous node. Join it and move our current node to here. So after the processing first element, our linked list will look something like this. Head will continue to remain here, and our current node now moves on to here. Next, we process 4. Again, we create a new node 4, mark its next to be none, join with the current node and move the current node to here. So now next our list looks like this. Current node. We will keep on processing the elements, and after the end of the traversal, our list would be like completely built up, and it would look like this. Current node at the end of the traversal will reside here, and head would continue to reside here. Now you would understand why we returned head.next and not head, because now -1 was a dummy node and it is not the actual value in our array. So we would move our head to the next node and then return this. So head would move here, this value is eliminated by the garbage collector, and memory would be freed, and now our linked list would be like this, and head would be here, and this is the value that is returned from the function. So yeah, so in this lecture we first discussed about what is linked list, why do we need linked list, what is its properties, and how to create a new linked list. Thank you for your time and have a good day.